Okay, here's an example of another quadratic equation with a linear equation. So we're doing a system, again, with quadratic and linear. Here, the only difference is that in our quadratic, y is also raised to the second power. So y also is raised to the degree of 2. But nothing changes in our process. We're also going to use substitution in this one. So right away, you should identify that in your linear system, your y variable is already set to negative 3x plus 10. So what that means is it's really easy to take this value of negative 3x plus 10 and solve that into our y variable in our first equation. Now, the only thing that's different here is when we substitute that into y, it just is going to require one extra step for us. So again, you're taking this value of negative 3x plus 10 and you're plugging it into our y variable from equation 1. So you'll see, before you do any of this math in your head, go ahead and rewrite your equation 1, but instead of putting y here, you're just going to substitute negative 3x plus 10 here. So you're going to be squaring negative 3x plus 10. So what you're going to want to do is go ahead and FOIL this binomial. So negative 3x plus 10 times negative 3x plus 10. So you're going to get 9x squared minus 60x plus 100. So this right here, 9x squared minus 60x plus 100, is what you get from squaring negative 3x plus 10. Next thing you're going to want to do is combine like terms. So here our like terms are 10x squared, and then you're going to want to set this, put this in standard form. So you're also going to subtract 10 from both sides. So you've again squared negative 3x plus 10. You combine like terms, and you subtract 10 to put this into standard form. Now, since you have a GCF here, you've got 10 as a GCF, you can divide everything by 10. And what that's going to do is that's going to give you x squared minus 6x plus 9. You're going to get a much smaller and more manageable quadratic to go ahead and work with. You'll notice here that this is a perfect square quadratic. You've got x squared minus 6x plus 9, so you should see that x minus 3 is perfect to work with. You can just turn that into a perfect square trinomial. What you're going to do is when you solve this, you by your zero product property, if you have x minus 3 times x minus 3, your only solution is x equals 3. Also, if you took the square root of both sides, x minus 3 equals square root of 0, which is just 0, you get x minus 3 equals 0. So x equals positive 3. Now, in order to get the y value for this, so you know that x equals 3, but remember, our solution here is going to be an xy pair. So in order to get your y value, you just have to take x equals 3 and plug it into equation 2. The reason you plug it into equation 2 is that equation 1 is just going to require a little more work. You've got y squared, and it's just going to take a couple extra steps. So you plug x equals 3 into equation 2, so you get y equals negative 3 times 3 for x plus 10. So you get negative 9 plus 10. So you get 1. So your solution is 3, 1. Now we want to check this by graphing the system. So what we want to do is I'm actually just going to pull up Desmos. And if you remember, our first equation was x squared plus y squared equals 10. And you'll see that's a circle right here. And our second one is negative 3x plus 10. So what we get right here is we get a circle and we get a line that goes through it. And what you're going to notice is it looks right here at, let's see, we had 3 and what was our other equation? 3 and 1. So let's go look back here. We get 3 and, sorry, I'm trying to remember what our equation was here. Y equals negative 3x plus 10. So at 3 and 1, we get our solution. So negative 3 and 1 is shown to be our solution right here. So this just proves that at graphing, our solution does work. And if you go ahead and click here, you also, shown by the graph that's in here, it shows that the point in which both our quadratic, which in this case is a circle, and our line, the point in which they intersect, is 3 and 1. So as in all the cases that we've done so far, the point or points that you're looking for are when each of your lines or parabolas or circles in this case. So it doesn't matter what type of equation we're looking at. In all of them, if you're looking at the graphs, they're the point at which they intersect. Or if you're looking at the equations, they're just the solutions, which are XY coordinate pairs of your system. And you also just solve these systems the same way we solve our linear systems, by either substitution or elimination. So just remember, as you're going through these, none of the processes that you're using are any different than when we did linear systems a couple chapters ago, or even back to Algebra 1 when you first learned how to solve systems of equations. So just keep that in mind, that your steps are exactly the same. So even if something looks different or more complicated, just keep sticking to the steps that you know, and it's going to end up working out as long as your math is correct. As long as the steps that you do are correct, you're adding or subtracting values from both sides, you're substituting the right values. Just stick with it. Even if you think it looks wrong, you're going to end up getting the correct answer in the end.